Hello and welcome to T3 Day 2 of Honors Precalculus. We're going to continue working with ellipses. Good time. So let's graph this ellipses. This is not in the form we want it to be in, so we're going to have to rearrange and do some completing the square. The first thing we'll do is we'll factor out a 49 from the grouping of x terms. So if you factor out a 49, you end up with this. And then if you factor out from the y term, the 25 is still leading coefficient here. You end up with 25y squared minus 6y. And then you move the 80, and the 804 is over on the other side already. So the question is, what do we add to turn this into a square, and what do we add here in the green? Well, we're going to add half of 4 squared, so we're going to add 4 here, and we're going to add half of negative 6 squared, so 9 there. But keep in mind, if we add this 4 on the inside, it's 4 times 49, so we have to add 4 times 49 here. And then we also have to add 9 times 25 over here to balance it out. So what you end up with is 49 times x plus 2 squared, because this right here, by completing the square, is this right there. And similarly, you end up with 25 times y minus 3 squared. And this equals, on this right-hand side, you have to add all these together. You end up with 1,225. You need the right-hand side to be 1 to fit the form we want, so we divide by 1,225, so you end up with x plus 2 squared, and then the denominator ends up being 25, and over here you end up with y minus 3 squared over 49 is equal to 1, and that's the form we want. What this tells us is that h is going to be equal to negative 2, because of that one right there. It tells us that k is equal to 3 because of that number. It tells us that a is equal to 5 and b is equal to 7, and that tells us a whole bunch. So the first thing it tells us is that the center is going to be at negative 2, 3, so that's going to be right here. And then what's going to happen is a is 5, so it's going to go 5 units to the right. So we're going to go over here and then 5 units to the left right there, because that the a is that left and right, and then you go up and down 7, so you go from 3 to 10 up here, 3 to negative 4 right there, and you can actually draw this real nice now. Draw this arc, draw that arc, draw that arc, draw that arc. Yeah, that arc could be better, so I'm going to make it a little better, make it a little symmetric there. So there's our ellipse. Now if you want to find the foci, remember the foci is going to be c squared is equal to the absolute value of a squared, so 25 minus b squared is 49. So c is going to be equal to the square root of plus or minus 24. So that's the distance from the center on the major axes. The major axis is the bigger one, so it's the distance. So when you do that out, what you end up with a foci. So foci 1 is going to be equal to negative 2 comma 3 plus the square root of 24. And then foci 2 is going to be negative 2 comma 3 minus the square root of 24. And you need a calculator to estimate that. What's that come out to be? It's like 7 point something on the first one. So it's right about here. There you go. So that's the first one, foci 1 right there. And then foci 2, it would add to me like negative 1 point something, like down here. It's symmetric. So what you can see here, this is foci 2. So this distance right here, this distance is c, and that distance is c. So that's c, and so is that. It's the same distance in each direction. So those are the foci. So there's a pretty cool thing called the eccentricity, which we'll call E of an ellipse. So another thing that E is, it's equal to the ratio of the distance from the center of the foci to the length of the semi-major axes. So it's C over A or B. It's either A or B. The length of the semi-major axes, either equal to A or B. So the one question here is, what do we know when E is equal to 0? When E equals to 0? So if E is equal to 0, that means that C over A has to be 0. So E would equal C over A. If that was equal to 0, the only way for a fraction to equal 0 is for C to equal 0. And if C is equal to 0, then A squared is equal to B squared by definition, because C squared is equal to this right here, the absolute value of that. And the only way for that to be 0 is for A squared to equal B squared. But if A squared is equal to B squared, A is equal to B, so you're dealing with a circle. So you can think of eccentricity as kind of like how far from being a circle an ellipse is. So when we consider the eccentricity of each of these ellipses right there, what we're dealing with is it's E is equal to C over whichever is bigger, C or A or B. And in this case, B is going to be equal to 3, so it's going to be C over B. And we know that C squared is going to be the absolute value of A squared minus B squared. So you end up with C squared is equal to the absolute value of 5, excuse me. Absolute value comes out to be 5 because it's 3 squared minus 2 squared. So C is going to equal to the square root of 5. So this will be root 5 over 3. That will be the eccentricity. Over here, we know that c is going to be equal to the square root of 49 minus 25. So you end up with the square root of 24 right there. So you end up with an eccentricity is equal to the square root of 24 over what's bigger, the square root of this over the square root of this. It's going to be 7. So you end up with eccentricity here is this, and this is this. There you go. Closer to 0, the closer it is to being a circle. So let's talk about orbitals. Very cool. The path of planets' orbits in our solar systems are ellipses with the sun as one of the foci. Pretty cool. When a planet is furthest from the sun, it is said to be at the aphelion, and then the actual distance is called the apogee. When a planet is at the closest, it is at the periphelion, and the actual distance is called the perigee. Pretty cool terms. I like it. The Earth's orbit has a semi-major axis of 149.598 gigameters, cool term, and an eccentricity of about 0.0167. So it's getting close to being a circle, but it's not quite because it needs to be 0 for it to be a circle. Find the equation of the Earth's orbit. Now what we're doing here is we're centering it at 0, 0. So it's just going to be x squared over a squared plus y squared over b squared is equal to 1. That's what we're looking to build. We know that E is going to be equal to c over a in this case. So we know that 0.0167 is going to be c over a, which is 149.598. It's the semi-major axes because it told us that. So c is going to be equal to 2.498. Right there. So now we know that c squared is equal to the absolute value of the squares of the difference of a squared and b squared. So we know that 2.498, that quantity squared, is going to be equal to 149.598 squared minus b squared. This is what allows us to find b. So therefore, when you do this out, use your calculator, you end up with b is equal to 149.577. And we expect the a and b values. So we expect this value and this value to be pretty close together because it's almost a circle. It's not quite. And we know it's almost a circle because this number is almost 0. So what that tells us is the equation is going to be x squared over 149.598 plus y squared over 149.577 is equal to 1. Be very careful with those decimals. So we use the eccentricity and the known value of A to find C, and then C allows us to find B, which is what we needed to finish the equation right there. So now it says find an equation in standard form, so that's the really nice one, of an ellipse. It tells us the foci and the major axes endpoints. So the first thing you can do is sketch these things to get an idea of what's going on here. So we know that the endpoints, we've got two endpoints, a negative 2, 1, and negative 2, 7. So negative 2, negative 1 is right about, let's put it right here. It doesn't have to be perfect, but negative 2, 1. And then negative 2, 7 up here is the other endpoint of the major axis, so the big one right there. So halfway between is going to be our center right there. So our center halfway between is going to be negative 2, 3. So that's super helpful right there. So now what do we need to do? Well, we know that therefore it's going to be x plus 2 squared over a squared plus y minus 3 squared, like this, over b squared is equal to 1. Well, we know that for the y right here, so the major axes, we know the distance from here to here, the vertical distance, it's going to go from 3 to 7, and it goes from 3 down to, that's negative 1 right there. So it's going to be 4. So that means that b, because of this distance, b is equal to 4. So that means now we know that it's y minus 3 squared over 4 squared is 16. And now the other endpoints that we know for the foci right here, are going to be at negative 2, 1. So negative 2, 1, there's one foci right there, negative 2, 1. And the other foci is at negative 2, I'm sorry, those are the foci, I did the foci right there, excuse me. Sorry. Negative 2, 1 and negative 2, 5. There's the other one right there. There's negative 2, 5 and negative 2, 1. So what that allows us to say, therefore, is that the distance, this right here is the c value, the distance on the major axes from the center to the foci. So that's from negative 2, 3 to negative 2, 1. So the distance from there to there, from 3 to 1 is 2. So that means that c is equal to 2. So therefore 2 squared is equal to a squared minus b squared. We know that a is 4. So we have 4 is equal to 16 minus b squared right there. So that means that negative 12 is equal to negative b squared. So b is going to be the square root of 12 right there. So what that means is, b. You'll notice I flipped that around. So this would actually be a right here, and a, and a, and a. All of those should just be a. So a is actually equal to the square root of 12. Sorry, it goes side to side there. So that means that you're going to have x plus 2 square root of 12 squared is 12. So this is our value there. So again, what we did is we graphed the endpoints. We got 7 to the midpoint, gets us the b value of 4. 4 squared is 16. And then we use the foci to get the c value, which is going to be from this 3 value to this 1, which gets us the 2 right there. And then you get the same thing. Remember, it's the absolute value, so you can flip them. In this case, it's going to be, that should be an A, and an A, and an A, and an A. And the last thing you should make sure you can do is type this into Desmos. Remember, when he says converge, I want you to use Desmos, so you can actually test these out to see how they look. Remember that you have to have 1 on the outside. That's the form you want it to be in.